All right, so let's do another easy one using this same technique. And then we're going to get into ones that we couldn't do in our head. So I made up this guy, x minus 7 equals 17. So you can tell from that, you would say, okay, well, it's going to equal 24, because I know 24 minus 7 equals 17. Let's do it algebraically. So what is our goal in life now, besides get through this class? Our goal in life is going to be to isolate the x, make the x all by itself, x equals something. So we notice that this x right now has an annoying minus 7. So you remember what I told you over here? If I see I'm subtracting 7, to get rid of that 7, I'm going to do the exact opposite on both sides. So I'm going to add 7 to this side, and I'm going to add 7 to this side. Notice I'm doing this down again, same kind of thing. It would behoove you to use this same technique in your homework. It'll be good for you. So once again, I have 7 minus 7, or negative 7 plus 7, and those are 0. So that's good, because then on this side, I'm going to have x plus 0, and on this side, I have 17 plus 7, 24. X plus 0 is the same as x. X equals 24. We get the same answer that we knew to be right in the first place. We can plug it back in. It checks. We're good to go. I hope that makes sense, because let's jump into some of their examples. And we are going to get lots of practice with this, because once again, this is something that is important in your whole career through science, excuse me, and in math, okay? So, number 2 on your paper, h plus 14.3 equals 79.1. Okay, so, Jackie, we can't really do this one in our head very well. We might know from fact families how to do this, but we're going to do it algebraically. I need a better color here. I guess I'll just use black. So, our goal in life, I said, is to get x by itself. Okay, change that. Our goal in life is to get a variable by itself. We have a variable of h. What is, I call it annoying it, that we want to get rid of? It's going to be this plus 14.3. So to get rid of the annoying plus 14.3, I do the opposite. So instead of adding 14.3 to both sides, I'm going to subtract 14.3 from both sides. And if you notice, I'm going to line this up nicely because it's going to help me later. So I have h plus 14.3 minus 14.3 is 0. That's why we do it. We want this to be 0 so that we can have h by itself. So now we just do some subtraction. Easy. We've got to do some borrowing, but we can do that. Minus 4 is 4, so minus 1 is 6. H plus 0 equals 64.8. This means that h equals 64.8. And then if you were really great, you would plug this back in. 64.8 for h plus 14.3 is going to give you 79.1. All right? So let's do another one. And if we were in class, we would totally be doing some of these for stickers. So it's just not as fun with the video. But we're going to grin and bear it because we need to move on. All right, number 3. J plus 0.6 equals 3 4/5. Now, what do you notice about this that could be a little troublesome and not very fun? Yes, fractions. We have fractions and decimals. We can't work with them very easily together, so we are going to pick one, and we're going to change it to either fractions or decimals. I choose decimals because this is pretty easy to turn it into a decimal. So let's just do that before we start doing our algebraic stuff. So we have j plus 0.6 equals 3 4/5. Well, let's work with 3 4/5. 3 4/5 is the same as 3, and if I multiply 5 by 2, do we remember doing this when we were making things into decimals? 5 times 2 is 10, 4 times 2 is 8. That's the same as 3 and 8/10, which is the same as 3.8. All right, well now I'm a little happier because I can work more easily with that. So now let's do our algebraic stuff. All right, so we want to get J by itself because he is variable. What's annoying him? A plus 0.6. What do we have to do to both sides? To get rid of this annoyance right here, we're going to do the opposite. We're going to subtract 0.6 from both sides. And look at again, I will line it up. And plus 0.6 minus 0.6 is 0. So I'm going to put J equals 3.8, and then I still have to go minus 0.6 on this side. So go ahead and do that. 6 and 3. J equals 3.6. So 3.6 plus 0.6 equals 3 and 4/5. That's not right. 8 minus 6 is 2, not 6. See? When I went back and plugged it in, I was like, it doesn't equal that. 8 minus 6 is 2, 3 minus 0 is 3, J equals 3.2. That is the correct way to write it, is to include the variable in it. You don't just put 3.2. The answer is J equals 3.2, and your next algebra teacher will love you if you remember to do that. Let's do another one. Number 4. And what do you notice about that one right off the top? That's a little different than what we've been doing. Q plus negative 7 equals 63. All right, our goal in life, get the variable by itself. What's annoying it? Plus negative 7. So if this is the same as Q minus 7 equals 63. Do you agree with that? I kind of like doing that better. So now I'm subtracting 7. So to make this Q by itself, I want to do the opposite. So instead of subtracting 7, I'm going to add 7 to both sides. Plus 7. And this is something you may have been doing in your head when you solved equations like this, or maybe you can think through it and you go, well, yeah, I know that I just have to add that over here. But this is something that's really good. So 7 minus 7, this is going to be 0. 63 plus 7, because we had to add to both sides, is 70. 70 minus 7 equals 63. It checks out. So we're good to go. Q equals 70. All right, let's do another one. I hope you're getting the idea of adding and subtracting to both sides and using that information and what you need to do to isolate the variable. Okay, so let's do number 5. R minus 12.1 equals negative 48. Okay, this one is going to show you why we spent so much time adding and subtracting negative numbers, because they are going to come back to haunt us. And actually, they won't haunt us because we already know how to do them. They're going to come back and keep visiting. So, our goal in life, get the variable by itself. This is an R. What's annoying it is a negative 12.1 minus 12.1. So we're going to do the opposite to both sides in order to get rid of that. So I'm going to add 12.1 to both sides. Well, 12.1 minus 12.1 is 0. I have R equals, now, negative 48 plus 12.1. Going back to adding and subtracting positive and negative numbers. What do we look at first? I know this was a while ago. Hopefully we had enough practice with it. When the signs are opposite, when we have one negative and one positive, remember what we do? We subtract, and then we take the sign of the bigger number. So we're going to subtract. We're going to say 48 minus 12.1, and the answer is going to be negative because this 48 is bigger than the 12. So I'm going to put the negative in right here so I don't forget it. How do I go 48 minus 12.1? Hopefully this is second nature to you. You know there's an invisible decimal place, and you put a 0 here. So now you can borrow 8 goes to a 7, that goes to a 10, it's going to be a 9. 7 minus 2 is 5, 4 minus 1 is 3, and I take the negative sign because that 48 is bigger than 12.1. R equals negative 35.9. Do you see how that would have been a little difficult to figure out in your head? But it will check. If you go negative 35.9, put that in here, minus 12.1, you're going to get negative 48. All right? So they're, now they add a little bit more difficulty, not difficulty, or maybe just something to trip you up a little bit, but nothing to be scared about.